In last video, we have seen communication through messages. Now let's look at another technique called shared memory. Here, instead of exchanging messages, multiple processes directly access a common memory region. Since everyone reads and writes from the same place, communication becomes much faster. Although shared memory provides excellent speed, it introduces another challenge. Since multiple processors are accessing the same data simultaneously, they must coordinate properly. Otherwise, two processors might try to modify the same information at the same time, resulting in incorrect data. So, why we need shared memory? Imagine multiple applications continuously accessing the same dataset. Sending messages repeatedly would create unnecessary overhead. Instead, allowing everyone to access one shared memory area significantly reduces communication time and improves overall system performance. So next we are going to see about emulating message passing in shared memory. So now comes an interesting topic. Even though processors share the same memory, we can still make them behave as if they are exchanging messages. Instead of sending data across a network, one process writes the information into shared buffer and another process writes it from there. From the application points of view, it's still looking like message passing. This is called emulating message passing in shared memory. Next, we are going to see about the basic concepts about this topic. So this diagram compares the traditional approach with the shared memory approach. In a distributed system, message travels through a network, but in a single computer, we can avoid network communication completely by storing the messages in the shared memory. This makes communication much faster. So these are all about the key points. The biggest advantage of this approach is performance. However, because multiple processes accesses the same memory, synchronization mechanism like mutex and semaphores become essential. This mechanism ensures that only one process modifies shared data at a time, preventing race conditions. This is let's take a practical example. In a CCTV recording system, one process continuously captures video frames from the camera while another process stores those frames on the hard disk. Instead of sending thousands of messages every second, both processes simply uses a shared memory region. This allows smooth and high-speed video recording. This is the real-time example. Here, another one example is about Microsoft Excel Online. Multiple users may edit the same spreadsheet simultaneously. Behind the scene, efficient memory management and synchronization techniques ensures that everyone's changes are reflected correctly without conflicts. So next one is concept about. So far we have seen message passing inside shared memory. Now let's reverse the idea. Suppose we have the multiple computers with its own memories. How can they behave as if they are sharing one common memory? The solution is a technique called distributed shared memory, where software automatically exchange messages between computers. So this is about the working principle. Although users feels like they are accessing one shared memory, every computer actually stores its own copy of the data. Whenever one machine updates the information, that update is sent as a message to the remaining machines. The software layer keeps everything synchronized automatically. Why do we need this? Remember, one computer can never directly access another computer's RAM. That's physically impossible across a network. Therefore, computer communicate by exchanging messages. The distributed shared memory software hides this complexity and creates the illusion of one computer memory spaces space. Next, we're going to see about the key points to remember about this concept, emulating shared memory and message passing. This technology combines the advantage of both approaches. Developers can write programs as if they are using shared memory, while internally the system handles message passing and synchronization. This concept is widely used in distributed databases, cloud platforms, multiple layer games, and collaborative applications. So, yes, going to discuss about shared memory versus emulated shared memory. Finally, actually, actual shared memory exists only within this single machine, making communication extremely fast. Emulated shared memory works across multiple computers where synchronization happens through the message over a network. Although it is slightly slower, it provides excellent scalability and allows geographical distributed systems to work together. So overall conclusion to summarize today's session, we explored two major communication techniques in distributed computing, message passing and shared memory. We also understand how these concepts complement each other through emulating techniques. In next session, we will build on these foundations and explore advanced synchronization mechanism used in distributed systems. Thank you.